Hi friends, I'm Anand Panchbait, Engineers Classes, and today we are going to learn things a bit differently. That we have got the entire theory in front of us. We are going to learn the power flow equation over here, which deals with transmission line chapter. So we people have learned in circuits and networks that how exactly ABCD parameters are working. We have also learned that how these ABCD parameters we are using into transmission line understanding. Performances of transmission line we people have seen, we have learned, which is solely based on this particular equations of transmission line, where VSIS is equal to ABCD into VRIR. What exactly we are going to do into this particular topic is that we are having some source over here, how much amount of complex power it is injecting and how much amount of complex power or load is taking from the transmission line, that we are going to find out. And ABCD comes over here. ABCD, they are the transmission line parameters. Fine. So obviously we have to take these things into account as well. So let's deal with power flow equation, how exactly we are getting it. So here we can make our first equation, Vs is equal to A into VR plus B into IR. So we got our first equation. Second equation, Is is equal to C into VR plus D into IR. Sir, why we have taken this? We are interested to find out the complex power. How to deal with complex power? So I know sending end complex power is equal to Vs Is conjugate, whereas receiving end complex power is given by Vr Ir conjugate. So I need the values of Vs, I need the values of Is conjugate. For finding Is conjugate, first of all I should know what is my Is. Fine. Okay, so it is really compulsory for me to find out the value of Is, cause Vs is already given. Secondly, I also have to find IR conjugate. For that, I should be having the value of IR. Then I can calculate what is IR conjugate. And when we talk about VR I already have. VR over here is taken as a reference phasor. That's why it is given as VR at an angle 0. And we are considering the Vs voltage, that is sending end voltage, is leading. It's leading VR by delta angle. And delta is also called as torque angle, or it is also called as load angle. That we'll be learning in upcoming chapters. Okay, and which is not the part of the curriculum in this semester. Now, from first equation the way I have told you that what I want two terms. One is IR, one is IS. So I have to formulate those terms. So I have IS with me, but I don't have IR. So I have formulated IR over here, which is in terms of VS and VR. Fine, so I've got it. Now I'll put this particular equation in second equation, so that I will replace this IR and I'll also get IS in terms of VS and VR. So I have got my IS in terms of VS and VR. So what have I done for that? Come on, let's understand. I have formulated IR. So this term will come over here, so it will become negative. So it is Vs minus AVR, which is equal to BIR. So Vs minus AVR, which is equal to BIR. Now B I take into denominator, so I'll be having IR, which is equal to 1 by B into Vs minus A by B into VR, which is my third equation. Then after we have kept this equation, the value of IR over here, so that what will happen? IR is a function of Vs and VR. Here I have VR, so now I have got my Is, which is the function of VR and Vs. Is it clear? So I have kept Is is equal to CVR plus D into the value of entire IR I have kept over here. 1 by BVS minus A by B into VR. I have done all the mathematical solution. We have done all the mathematical calculations over here. And finally, you can also do it. And as such, everything is written over here so well. Yeah, but one thing we have to remember, when I take LCM over here, BC minus AD, this is nothing but minus 1. AD minus BC is 1 for symmetrical network. So that's why as we are taking we are having a symmetrical network, BC minus AD will become minus 1. So that's why it's minus 1 upon V into VR, and this is D by V into Vs. So I wanted these two terms. So I have calculated IR, I have calculated IS. Fine. Now, as I am supposed to deal with complex numbers, I have to replace this ABCD, which are parameters of the transmission line, in their polar form. Fine. So how will I be able to deal with it in polar form. So A is equal to mod A at an angle alpha, B is equal to mod A at an angle alpha, just because I have told you my line is what kind of a line? It's a symmetrical line. For that, A is equal to D. So we have got A is equal to D. Now let's deal with B, which is equal to mod B into beta, and D is also done. I don't require C because in this equation we don't have C. In this equation also we don't have C. So we can say that put all above values in equation number 3. Equation number 3 is the equation of IR. It is the equation of IR. ये पता चला कि नहीं पता चला? So now we can say that I'll put B it's mod B at an angle beta, Vs it is at mod Vs at an angle delta, A at an angle alpha, B at an angle beta. All these values I have kept over here and I have got a final IR equation. Fine, okay. This beta, so it is delta minus beta I have over here, and here alpha minus beta I have over here. Fine. Now let's deal with put ABCD values in equation number 4. All these values I'll be putting over here as well. So I'll be having mod D, mod Vs, mod B. Fine. D has an angle of alpha, B has angle of beta, and Vs is angle of delta. Fine. But now it is not coming into the. I am so sorry that I was in the flow. That thing is not coming in the camera, so we have to shift the camera. So please, we'll be having a break over here for a while.